Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to be talking about advanced gas laws. More specifically, how do we get to the molar mass equation and the density equation of a gas using PV equals nRT and another equation for molar mass that's been rearranged. Now, I said this equation's been rearranged because typically when I think of molar mass, which is going to be signified by cursive M, molar mass typically has the units of grams per mole. So if I wanted the molar mass of aluminum, I'd look it up on the periodic table and it would say 27. It'd be 27 grams per mole would be the unit. Okay. Well, to get to molar mass, you would need the mass in grams over the moles, okay, which is going to be N if it's a gas, okay, in order to get molar mass. This equation, okay, is just rearranged to be N is equal to M over cursive M, which is molar mass. But we're going to be using this equation with this equation to get to a molar mass and density equation, okay? If you are lucky enough to be in the AP chemistry curriculum, this equation is actually given to you. It's not one that you have to know. So if you're taking college chemistry, probably one you just need to know. And I think everybody should know PV equals nRT. So let's get into the video where we're going to calculate molar mass and density of a gas using a combination of both of these equations. So we're going to start out with PV equals nRT. And what we're going to do is we're going to substitute N right in here. So we're going to take M over cursive M and put it in right where the N is. So PV is equal to M over cursive M RT, okay? And then we're going to do some simplifying, okay? So PV is going to be equal to MRT all over cursive M, and remember cursive M is molar mass, okay? And what I want to do is I want to solve just for the molar mass. And I just want to do a quick pause and remind you about cross multiplication. For example, if we had two fractions, we could take the numerator of the first times the denominator of the second, so 2 times 6, and that would be equal to 3 times 4. We can do that, okay? But we can also just move one of these things up and it would still work. So I could just move this up, okay? So 6 times 2 is 12 divided by 4. That would be 3, which would be the same thing as this side of the fraction. So just to let you guys know, when it comes to cross multiplication, you can move things diagonally, okay, any way that you want, and the math still works out, okay? So in this case, I'm going to be solving for molar mass, but I want to have two fractions. So pressure and volume over 1 are the same thing. And what I'm going to do is that same thing that I just did before with the fraction is I'm going to bring up the molar mass here, and I'm going to bring the PV down here, and it ends up being a legal move. So once again, I'm going to bring this up, okay? I'm going to take this part of the fraction, and I'm going to bring it down. And that result is that molar mass is equal to MRT over PV. And this is an equation, okay, that most people are not familiar with, and that's why we call it an advanced gas law. Now we can go a little bit further with this, okay? We can see that mass divided by volume is actually density. So we could rewrite this one as that density RT over P. This is another equation that we could come up with by deriving, or rearranging these equations. Once again, all I took was the mass divided by the volume, and I made that density. Of course, if I wanted to solve for density, I could just take this equation, I rewrite it, and I'm going to move some things around. So if I want to find density, okay, I'm going to move everything over to the other side. So I'm going to bring the P up, and this RT part right here, I'm going to bring that down, okay? So that will end up becoming density is equal to, let's see, it's going to be P and M as a numerator, and then R and T as a denominator. Okay, so we got these, three equations, okay? One for molar mass right here, okay, where you have M and V. Another one for molar mass where M and V have been reassigned as density, okay? And then we have density all by itself from using these two equations. So let's do some practice problems, okay? Where are you going to see some of this pop up, okay? Let's do this one first, okay? So take a screenshot of it, maybe try the problem on your own, pause the video, and then come back and I'll be working on it. It says calculate the density, okay, so I'm probably going to be using this equation for sulfur hexafluoride gas at 707 torr and 21 degrees Celsius. So the pressure is 707 torr, which I'm not a big fan of. I'd rather have that in ATM, so I'm going to convert that over. I have the temperature at 21 degrees Celsius. Once again, I don't like that. I'm going to convert that over into Kelvin, okay? And I'm going to plug them into the equation. So I'm going to have pressure, temperature, I have the R, okay? And the only other thing I'm going to need is molar mass. So I have to calculate the molar mass of sulfur hexafluoride, which is 1 sulfur and 6 fluorines, and that has a molar mass of 146.1 grams per mole. Okay, 707 torr converted over to ATM, and I do that by dividing by 760. Is going to give me 0.93 ATM. 21 degrees Celsius into Kelvin is going to give me 294 Kelvin, and I did that by adding 273. And then I just plug all this stuff into the density equation, which I've already derived here. So the pressure is 0.93 ATM. The molar mass is 146.1 grams per mole. The R is equal to 0.08206, and there's a lot of units on that. ATM liter over mole Kelvin with a temperature of 294 Kelvin. Let's cross out some of these units. So ATMs cancel out, Kelvin cancels out, okay? The moles cancel out, and I'm going to be left with grams per liter, okay? And if I work this problem out, I find out that it's 5.63 grams per liter for this particular problem, okay? Let's take a look at one more, okay? Take a screenshot of this problem, okay? And let's work it out, okay? This one says calculate the molar mass. So I'm going to be using one of these two equations, okay? For a gas that has a density, okay, so I'm probably going to be using this one because this is the one that has density in it, of 7.13. Okay, so let's separate this problem. So the density is 7.135 grams per liter, okay? It has a temperature of 12 degrees Celsius, so I don't like that. I'm going to move it over to Kelvin, and a pressure of 743 torr. And I don't like that either. I'm going to switch that over to ATM. Okay, so let's go ahead and change the 12 degrees Celsius into Kelvin. And if I add 273, I get 285 K. The 743 torr into ATM by dividing by 760 gives me 0.978 ATM. And I think I am now ready to plug everything in to this equation where it says the molar mass is equal to the density. I'll just plug in the numbers. The density, which is 7.135 grams per liter, times R, which is 0.08206, lots of units, ATM liter over mole Kelvin. Okay, I'm squeezing everything in here, and at a temperature of 285 K. And that's going to be all over a pressure of 0.978 ATM. Okay, let's see what cancels out here. Okay, ATM cancels out, Kelvin cancels out, liters cancel out, and I'm left with grams per mole, which is great for molar mass. It should work out that way. And when I do all the math here, it comes out to 170.6 grams per mole. And that's how you take care of advanced gas laws. If you found this information helpful, please give it a like and subscribe and add a comment.